Hello everyone, this is Akash, and in the last video what we have seen what is a deductive database, and we have seen what are the problems in the relational database system and how to overcome them using deductive databases. So today we will discuss about data log. So data log is something that can be used to solve those problem, and using these recursive rules we can actually create data log, and we can overcome this problem what we have seen in our earlier video. So in this video I am taking the example what I have taken in the last video, that is the assembly relation. And data log means that data log is a set of rules. So for this relation we have defined two rules. This is rule number 1 and this is rule number 2. So for any data log, it consists of two components. This is the first component and this is the second component. This component is called body and this component is called head. So in case of data log, it consists set of rules, and the first component is called head of the data log or rule, and the second component is called the body of the data log. And our relation is body implies head. It means if we have some tuple in our body, then that tuple should be present in head. That means if body is true, then head should be true always, and if body is not true, then head can be true or head cannot be true. Okay, so our objective is to find the components of each part, and this component can be the recursive components. For trike, what are the components of trike? Wheel and frame. And what are the components of wheel? Tire, spoke. And what are the components of tire? Component of tires are rim and tube. So from starting from trike, we need to reach to tube. So we need a component table. This will be our output, that is the component table. It consists of two attributes, part and subpart. So our first rule says that if there is some tuple in assembly, then those tuples should present in component, because if there is something present in body, then that should be present in head. So in our first iteration we can have everything, because this is the assembly, and all the tuples which are present in assembly, that can be moved to component relation. So I am just copying everything here. Okay, so you can see I have copied everything from assembly to components relation. Okay, so this is the first rule. It says about everything that is present in body, that should be moved to component. And the next rule says that if there is some tuple in assembly relation, and assembly relation consists of part, subpart and quantity. So here I am assuming that our subpart is x, and that tuple is also present in component, this x, because here something that is a subpart and here it will be a part. That means something is subpart of assembly should be a part of component, and for those part what the subpart we have, that should be moved to component relation. So let us try to find out take this tuple, first tuple, trike, wheel, 3. So trike, wheel, 3. We get one tuple here, and now we need to search a tuple. So I am writing it here. Okay, this is trike, this is wheel, this is 3, and now I need to search for a tuple in component relation where wheel will be a part. So I need to search. Okay, I got it. I got 2 tuples here for which wheel is a part and it has some subpart. So our component relation will get 2 tuples, 2 new tuples with trike as the part and spoke and tire will be the subpart. So I will be writing it here, trike, and subpart will be spoke, and then again trike, subpart will be tire. Okay, again I need to search this in the similar way, because looking at this relation you can check this is a recursive relation, because that is something present in head, they are also in the body. That means function is calling itself again and again. So in the next iteration again we will check if some new tuples are generated or not. Okay, let us check. For the next tuple, here we have trike, frame and 1. So we have trike, frame, quantity is 1, and we need to search for a tuple in components where frame is a part. So in component relation, look, there is I got frame, and frame is a part and seat and pedal is a subpart. So again I need to add trike and seat and trike and pedal in our component relation. Trike and seat and trike and pedal. Okay, again search for the next tuple. In the next tuple we have frame, seat. Now again check here if seat is some part of this tuple. No part, no tuple contains seat in their part attribute. Check for the next attribute, frame, pedal. Pedal is not there. Okay, then wheel, spoke. Then search for spoke. No, there is no spoke. Then wheel, tire. Then search for tire. Yes, we got tire here. We got tire. So what I will write? I will write wheel, because what I get here? I get wheel, tire, 1. So wheel, tire, 1. Tire will be a part, and for this tire I have one subpart, rim and tube. So I need to write here wheel, tire, okay, rim and wheel, tube. Okay, then I need to again search for the next set of tuples, tire, rim. Let us check there is any rim available in the tuple. No rim available. Then tire, tube available or not? No, tube is not available. Now can we say that our we have to stop now? Yes, we can stop now because no tuples will be generating now. Because if you see in the recursive relations, there should be a breaking condition, and the breaking condition we need to define. So for this type of data log, the breaking condition is when the last iteration the set of tuples generated, and in the current iteration the set of tuples generated, when they are same, then will be stop. So if I again try to iterate over it, and we cannot find a new tuples will be generating here, so we need to stop here, and this will be our final result. Now our objective is satisfied by this component relation. If I tell you for trike what are the subparts, so you just write a simple query, select star from components where part equals to trike, then trike, 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 trike. So for trike, those are the subparts we need. And then for wheel also you can check in that way. So in this way you will be generating all the tuples that you will be needed for your relation. Also, I hope you understand this video, and if you have any doubt, please try to write this in the comment section. And in the next video I will be showing you how to write the recursive queries, because that is a definition and we need to write the SQL queries. So in the next video I will be writing the SQL queries for this. Okay, thank you guys.